So what our packet gives us our basic ideas if we don't have a graph. We have three cases. One, we can try we're looking at the limit as x approaches some number. That's what this tells us, the limit as x approaches a. And we're looking in your packet, we're on the finding limits algebraically classwork page. That's what we're looking at now. So we're interested in the limit of a function as x approaches some number. So we're not looking at x approaching infinity yet, just some number. We can try three things. We can plug in that number. If our function doesn't give us any kind of problem, if we're not dividing by 0, if we're not taking the square root of a negative number, then we can plug in that number to find our limit. If we do get some kind of problem, if we're dividing by 0, something like that, we can try to factor and cancel. We try to see if we can factor the numerator, factor the denominator, and cancel something out, and then see if we can plug in our number, and it doesn't give us, see if it doesn't give us a problem after we factor and cancel. If neither of those steps work, then our limit is going to be plus or minus infinity, or it doesn't exist. And we're going to look at each of those cases separately. So for the first, we're looking at example 1. Again, we're in our packet, the finding limits algebraically. So for the first one, we're looking at the limit as x approaches -2 of x squared minus 4x plus 1. This function isn't going to give us any kind of problem if we plug in -2. We're not going to divide by 0. We're not going to be taking the square root of a negative number. So we'll just plug in -2, and if we do that, we get -2 squared minus 4 times -2 plus 1. We just plug it in. So our limit equals 13. Just plug it in to find our limit. If our function doesn't give us a problem, plug it in to find our limit. And these, when you can find your limit by plugging in, you have a nice function, and it makes your work a lot easier. So for the second example, we want the limit as x approaches -2 for this function, 2x minus 6 over x minus 2. When we plug in -2, it doesn't give us a problem. -2 minus 2 in the denominator is -4, so we're not dividing by 0. So we just plug in 2 times -2 minus 6 over -2 minus 4, and we get 5/2. What is it?
-2, not 4.
Oh, yes. I was thinking of the answer. So we get a fraction, we can reduce it to 5/2. So this one doesn't give us a problem. So let's look at the next one. We want the limit as x approaches -2 of minus x squared minus 2x minus 8 over x squared minus 4. If we plug in -2 here in the denominator, -2 squared is positive 4, and we have positive 4 minus 4, so we get a 0 in the denominator. And if we plug it into the numerator, we get 0 also. So we get a fraction that tells us 0 over 0. 0 over 0 is undefined. So that's not, we can't say that's the limit. So what we have to do, if we get some kind of problem, is we have to factor. So I'm going to factor the numerator, factors to x minus 4 times x plus 2. And the denominator factors to x plus 2 times x minus 2. And now we can cancel, and this is x minus 4 over x minus 2. And now if we plug in -2, we don't get a problem. So we plug in -2, we get -2 minus 4 over negative 2 minus 2. So we get negative 6 over negative 4, which equals 3/2. So our limit here is 3/2. Questions so far? All right, so here we have the limit as x approaches 1 of x squared minus 2x plus 1 over x cubed minus 1. First we try plugging in. We plug 1 in to our functions, and we get 0 over 0. So that doesn't help us out. We get a problem.
What if you get like 0 over 1? It still doesn't.
So let's take a look. Let's factor this. So if I factor the numerator, my numerator factors to x minus 1 times x minus 1, and my denominator factor to x minus 1 times x squared plus x plus 1. So I factor the numerator and denominator. One of these cancels. So I just get x minus 1 over x squared plus x plus 1. Now I'm going to plug in 1 in here. So when I plug in 1, I get 1 minus 1 over 1 plus 1 plus 1. So I get 0 over 3. Well, if I get a 0 in the numerator, what does that tell me my function equals? 0. If I get a 0 in the numerator, that's fine. We just end up with 0. So my limit there is 0. Thanks, Abe. She's not here today. So if you get a 0 in the numerator, you're okay. It just means it equals 0. If we get a 0 in the numerator, it's when we get a 0 in the denominator that we have a problem. Okay? Questions on that so far? All right, so let's look at what happens if our function is positive infinity, negative infinity, or does not exist. So if we do steps 1 and 2, if we plug in and we get a problem, we factor and we cancel, and we still get a problem, then our conclusion is what we figure out from that. If we do both of these steps and we still have a problem with our function, with our limit, then we know that our limit is going to be positive or negative infinity, or it doesn't exist. So let's take a look at how we figure that out. So again, we've done steps 1 and 2. They don't work. We still have a 0 in the denominator, so we still have a problem. So that tells us that our limit is positive or negative infinity, or it doesn't exist. So to find out which, what we do is we split our function up into 2 parts. We look at the limit as we're approaching from the left side, and we look at the limit as we're approaching from the right side and see if they're the same. And what we're looking at is the sign of our function on the left and on the right. So what we're going to do, what it tells us to do here, is we're going to plug in a number close to A on the left of A and see what we get. And we're going to plug in a number close to A on the right of A and see where we get. If they both have the same sign, if they're both the same sign, our limit is positive infinity. If they both have a positive sign, our limit's positive infinity. If they both have a negative sign, our limit's negative infinity. If they have different signs, our limit does not exist. So let's take a look at this function. We want to find the limit as x approaches 2 of 2x plus 5 over x minus 2. If we plug into what it tells us here is we get 9 over 0. That doesn't help us out. We can't factor this and do any cancellation. So after trying the 2 steps, we still have a problem. We still have a 0 in the denominator. That tells us our answer is going to be positive or negative infinity, or it does not exist. So we're going to look at a number on the left of 2. Two is the number that we're approaching. We're looking for our limit. So on the left of 2, I'm going to choose on the left of 2, I'm going to choose 1.9. So 1.9 is a little smaller than 2, so it's going to be left of 2. And I'm going to plug in 1.9 into my function. So I'm going to plug in 2 times 1.9 plus 5. And on the bottom I get 1.9 minus 2. And when I calculate that out, I get 8.8 over negative 0.1, which is negative 88. So I get a negative sign here. On the right of 2, I'm going to pick a number a little bigger than 2. So we're going to the right. So I'm going to let x equal 2.1, just a little bit bigger than 2. And we'll see what we get here. So we're going to plug that in. 2 times 2.1 plus 5 over 2.1 minus 2. We get 9.2 over 0.1 equals 92. So this is negative. This is positive. Our signs are different. So this tells me the limit does not exist. If both of the signs turned out to be positive, that would tell me my limit was positive infinity. If both were negative, it would tell me my limit is negative infinity. So what this graph is going to look like as we get close to 2 is our graph is going to look like this. And we'd have an asymptote this way. Sorry, I drew it backwards. It would be this way. And we'd have an asymptote here. So on the left, it goes to negative infinity. On the right, it goes to positive infinity. So this would be a very, very rough sketch of what the graph looks like. If they're both positive, our graph would look like this. And if they're both negative, our graph would look like this, going down. Yeah, Cedric.
Why did you have to choose like one off of the original number?
I just wanted to choose a number that was close to 2 on either side. What's that? No. So the question Cedric asked, that's a good question. Could I have chosen, on the left, could I have chosen 1? And on the right, could I have chosen 3? Yes. I could choose those 2 numbers. And on the left, my answer, if my answer is negative, you should get a negative answer and a positive answer. Now, you want to choose close to your number because your function could, my function could do something like, let me get a new page here. So we said the graph looked something like this. But as we go out here, the graph could come up like this. So if we go too far out, then this is, or our graph could go back down like this. And on this side, our graph could go up like this. So if we go too far out, we get a positive number here and a negative number there. So you want to choose pretty close to your number.
So
One off would probably be okay. But you want to choose a number close to your original number. Because you want to see what your function is doing close to 2. We're not interested in what it's doing far away from 2. We want to know what it's doing close to 2. All right, let's look at a couple more of these examples, and then we're going to move on to limits as x approaches infinity. So let's look at example 7. We are looking at the limit as x approaches -3 of x squared plus 2x minus 3 over x squared plus 6x plus 9. So our first step is plug in. If we plug in -3 here, if we plug in -3, we get 0 over 0. I'm not going to go through the calculations.
Does not work.
So that doesn't help us out.
I say it doesn't work.
For the second step, we want to try to factor. So that's our second step in finding our limit. If I factor this, I get x plus 3 over x minus 1 times x plus 3 times x plus 3. So I get I cancel an x plus 3. I plug in again, and I still get, when I plug in, I still get 0 over 0.
Doesn't work.
So that still doesn't work. I'm plugging in -3. I'm sorry, I don't get a 0 over 0. I get -2 over 0. I get -2 over 0 when I plug in. So I still have a 0 in the denominator. So for this one, the first two steps don't work. So I have to check my signs. I need to plug in close to 3 on the left and close to 3 on the right. So on the left, I'm going to plug in, I'm going to do that up here. On left, I'm going to say x equals -4. So on the left, we plug in x equals -4. And when I plug that in and calculate, I get 5 over 1. On the right, I'm going to plug in a little bit further to the right. So on the right, I'm going to plug in x equals we could do -2, we could do 0. What I plugged in even a little further to the right. I plugged in x equals, let's plug in x equals 0. X equals 0 is on the right. So let's plug in x equals 0, and I get -3 over 9 equals -1/3. So on the left we get 5, a positive 5. On the right we get a -1/3. So our limit does not exist.
Would it not be? Do they both have to?
They have to be this. It has to be the same sign on the right and the left for the limit to exist. If they were both positive, we'd get infinity. If they're both negative, we'd get negative infinity. Yeah.
Okay.
How come the numerator is -2 if you're plugging in -3?
Oh, this should be, let's see, -3 minus 1. It should be -4. Thank you. So our signs are different, so our limit does not exist. I want to look at one more example with this piecewise function because it's just a little bit different. And then we're going to look at limits at infinity. So we're looking at number 10. We want the limit as x approaches 2 of this function. So what we do here is if we plug in x equals 2 to these functions, if we plug in x equals 2, I get 2 over 0 for this one, and I get -1 over 0 for the bottom one. So this doesn't work. Plugging in doesn't work to give us our limit. We can't factor any of these. So we need to look at we need to plug in numbers close to 2 on the left and on the right. Now with a piecewise function, you have to be careful which function you plug it into. On the right of 2, x is greater than 2. So on the right of 2, we're plugging into this function. On the left of 2, our piecewise function tells us for x less than 2, that's on the left of 2, we plug into this function. So on the left, I let x equal 1. So we're just a little bit to the left of 2 here, and I plug that in. So my function is 1 minus 3, I'm plugging into this function, over 1 minus 2, equals negative 2 over negative 1, which is 2. On the right, so I'm going to go just to the right of 2 a little bit. I'm going to plug in x equals 3. So at x equals 3, my function, I'm using this function now because I'm bigger than 2. I get 3 over 3 minus 2, which is 3 over 1. Yes, so both of these are positive. Both of these are positive. So the limit is equals infinity. Yes? The function rule tells us for x greater than 2, we use this one. For x less than 2, we use this one. So that's how we decide which one to plug in. It depends on what the function tells us. Okay? Questions on this? All right, let's look at limits as x approaches plus or minus infinity. So these rules should be a little bit familiar to us, because these rules are the same ones we used when we talked about asymptotes. So these rules should be a little bit familiar to us. So for the previous questions, we were looking at the limit as x approaches a number, some number. Here we're looking at the limit as x approaches infinity. We have 3 rules, just like we had 3 rules for asymptotes. If the power in the numerator is smaller than the power in the denominator, so the power of the denominator is bigger, they call it bottom heavy. So if the power in the denominator is bigger, then the limit as x approaches infinity from either direction, positive or negative infinity, the limit is 0. So this is just like when we said that when the power in the numerator is bigger, we had a horizontal asymptote at y equals 0. It's the exact same rule. So our limit is 0. If the power in the numerator is the biggest, then we're going to have our limit as plus or minus infinity. So if the power of the numerator is bigger, we have plus or minus infinity. That tells us we have a vertical asymptote. And to figure out whether it's positive or negative infinity, we're going to plug in a really big number for x to see if it's positive or negative, or a really small value of x, like negative 10,000, and see if the sign is positive or negative. And the sign is going to tell us whether our limit is plus or minus infinity. Our third rule is if the powers are equal, then the limit is the ratio of the leading coefficients, just like we talked about with with asymptotes. If the powers are equal, the limit is the ratio of the leading coefficients. So it lays out the rules really nicely for you here. So I'm not going to redo them in any way. They tell you really nicely how it works here. So I just want to look at a couple of examples and then set you loose. So number 12. Number 12, we have 4x squared plus 50 over x cubed minus 85. The highest power in the numerator or denominator? Denominator. So they call that bottom heavy. If it's bottom heavy, the limit is 0. And we're approaching plus or minus infinity here. So please make sure you note here we're not approaching a number. Whoops, I'm sorry. We're not approaching a number. We're approaching infinity. So because this is bottom heavy, because the exponent, the power on x is 3 in the denominator, the power on x, the highest power is 2 in the numerator. All right. Number 13, power of the numerator, denominator, which one's bigger? They're the same. So the limit is the limit, or is the ratio of the leading coefficients. So the limit, the leading coefficients are the numbers in front of the highest power on x. The limit is 4/5. Number 14, highest power in the numerator or denominator? Numerator. So this is what they call top heavy. So this tells us that the limit is going to be plus or minus infinity. And what we're going to do, we're approaching, x approaches infinity. So we're going to plug in a really big number for x. If we plug in 10,000 for x, we're going to get 30,000 minus 23 in the numerator and 40,000 minus 1 in the denominator. Both of those are positive, so we get a positive number. We're just going to plug in a really huge number for x and see if our sign is positive or negative. If I plug in a really huge number for x, my sign is going to be positive for my function, so the limit is positive infinity. Let's look at number 15 now. Number 15 is a little tricky. The limit as x approaches infinity of 4x minus 5x squared plus 3 divided by 1 over x. We could look at the powers, but rather than doing that, let's simplify this a little bit. When we divide by a fraction, what's the same as dividing by a fraction? Multiply by the reciprocal. So I'm going to say this is 4x minus 5x squared plus 3 times x over 1. And put a parenthesis here. So we can just distribute my x. So this is just 4x squared minus 5x cubed plus 3x. So we're just looking for the limit as x approaches infinity of 4x squared minus 5x cubed plus 3x. And we find this by, now this, if we think of our rules, what's the power in the denominator? What's the power on x in the denominator? 0. So which numerator denominator has the highest power? The numerator, so it's top heavy. So this is top heavy. So we can plug in a really huge value of x to see if our limit is going to be plus or minus infinity. If I plug in a really huge value of x, I get a positive number here. So the limit equals infinity. And then I just want to look at one of these last two, and then we'll be done. I'm not going to go all the way through. I just want to give you a way to think about these. So if we look at this and we're looking at our rule, and we want to know, is this top heavy or bottom heavy? In the numerator, we have our highest power of x is x squared, but we have a square root. So what's the square root of x squared? X. So we can think of the numerator as having the power of the highest power of x being 1. So the square root of, we're just looking at the highest power of x, the square root of x squared equals x. So if we're just looking at the powers, we can think of this as x over 2x being the highest powers. So I'm just ignoring this minus 3x. I'm just looking at the highest power on x. The highest power on x here is x squared with a square root. So the power of the numerator and denominator are both going to be 1. So they're equal powers. So the limit is going to be on this one -1/2, because we have to be a little careful with this. We plug in, if we plug in a very large, is this a negative infinity? Positive infinity. Negative infinity. So if we plug in a really big negative number in the denominator, it's going to make the denominator negative. So this limit is going to be -1/2. But if you see this square root, x squared and a square root, you can think of that as being a power of 1. All right, questions? Know everything you need to know about limits. So homework. There are a lot of problems on there. Let's just do the, I'm going to say evens or odds. Evens or odds. And skip, if you do the evens, skip number 14. And let me see any others. The others look okay.
For absolute value, just assign for
Number 20.
x plus 5.
Oh, no.
X might, you just make the answer positive.
Right. So on that one you just calculated. Right, right.